Hello, my name is Panagiotis Vlantis and I am here to present you our work, Robot Navigation in Convex Workspaces using Harmonic Maps. In this work, we address the problem of coordinating the motion of a robot operating inside a static but realistic workspace. To cope with the workspace's complexity, we use harmonic maps to transform any bounded 2D workspace with arbitrary connectedness directly to a punctured disk. This is accomplished by designing an algorithm which, given a function that maps the outer boundary to the unit circle, selects appropriate locations for collapsing inner obstacles into points such that the resulting transformation is a diffeomorphism. Furthermore, we design simple, closed-form harmonic function-based potential fields in the transform workspace, which, coupled with appropriate adaptive loss for their parameters, guarantees safe convergence to the goal from almost all initial configurations without requiring offline tuning. Finally, to address large and thus computationally expensive workspaces, we exploit the properties of the proposed control scheme to build an atlas of harmonic maps. More specifically, given a partitioning of the workspace into a set of small and possibly overlapping regions, we construct a harmonic map for each partition with the additional property that the regions on the outer boundary, which are free from obstacles, get also mapped into points. Thus, given a sequence of partitions connecting the robot's initial and final configurations, for each intermediate partition we place a temporary goal on such a boundary point in order to navigate to the next one, without compromising safety or overall convergence properties. Finally, an extensive simulation study was conducted to verify the efficacy of the proposed control scheme. Thank you very much for your time.